Bismillahirrahmanirrahim. This is another question from Fourier Transform, chapter number 18. Here we'll be discussing example 18.8 solved in the book. And this is on the request of a student from University of Namibia. Let's see. This is the question. Use Fourier Transform method to find IOT. So this is IOT current. We have to find this, where IS is 10 sin 2t. So the input signal is given here. So as we have done in the previous case, or the previous example 18.7, that first of all we have found the transfer function, which was V O out and V out omega, V I omega. So in our case now we have currents given, so we'll find the H omega in terms of currents. So the transfer function will be I out divided by I in. But first of all, we have to convert the circuit into frequency domain. So capacitor, you know, is 1 over j omega c, putting the value. So for the capacitor, we will have to write 2 over j omega. And the input signal is the transform, or the Fourier transform of sine omega t is shown here, given in your table. So we'll be using that. Now IST is given 10 sin 2t. Therefore, in our case, keeping this in view, it will be j pi 10 and delta omega plus 2 minus delta omega minus 2. So the Fourier transform signal now will look like this. Here we have just changed the capacitor, and we are calling these now IS omega and IO omega. Now the transfer function, as we have said, that it will be I out over I in. Now how do we find out I out when I in is given? You can see this current is dividing into two paths. So by current division rule, we can find the current in this branch. So by CDR, or current division rule, we know the total current divided by total impedance. So this is 2 plus 4 plus j, and multiplied by opposite arm. So we are going to find current here. So our opposite arm is this one. So we multiply by 2. And from here now we move IS to the left hand side. So we get this function. Now taking LCM at the denominator. First of all adding 4 and 2, 6, and then taking LCM, it will become like this. And simplifying, or taking 2 common, will be 1 plus j omega 3. So this is our transfer function in this case. Now we have input signal, we have the transfer function. So the formula for output using transfer function was this formula. So we'll plug in now the values. So this is H omega and then the value of IS. Now J and J multiply will become J square. Rest, I hope you can follow the multiplication. Then pi omega. Now this is the only critical part which some students might miss. Now J square is actually equal to minus 1. We write that, and then we multiply by minus 1, whole thing. And just manipulating the negative, we are going to bring here, and the positive sign here. So this is our IO omega. Now to transform this into the time domain, we have to find a formula which can transform this. Unfortunately, the transform table does not have any formula which we can use here. Therefore, we have to now use the derivative formula or the original formula for this, which was inverse Fourier transform formula. And this is the inverse Fourier transform formula. So we'll be using this formula. So we'll be using this formula now. And all we have to do is replace the f omega in the formula by I omega naught. So this whole thing comes here, and e raised to the power j omega t d omega. Now we need to simplify this. For this, what we are doing is we are taking 10 pi common, 10 pi divided by 2 pi, and then we separating these two terms. So it will be omega and delta omega 2, omega minus 2 divided by 1 plus j3 e raised to the power j omega d omega. Similarly, the second term will be as shown here, omega multiplying with both here and here as well. Now there is a formula. Let me just explain. The formula says that integral of delta omega minus omega naught f omega d omega is equal to f omega naught. Now what does this mean? Let me explain. We know the direct delta function is like this. Its value is 1 only when omega is 0. At all other places, delta omega has value 0. So if we multiply by 0, the function will become 0, except for where delta omega is 1. Now when we shift this function to a place called omega naught, then what will happen that at this place, the signal will have a value 1, and all other places it will have value 0. So that means that this function is 1, this function is 1 at only this point, and therefore f omega is also valid only at this point. So 1 multiplied by f omega at this point means actually f omega naught. We'll use this formula. First of all, we are going to arrange this in exactly matching with the formula given here. So we first write down delta omega minus 2, then all the other things except for d omega. So this is our function. You can see from here, this is the function. And similarly, for the second case also, this is the function. Now all you have to do is put in the function omega is equal to omega naught. Now omega naught in our case is 2. Compare these two. So we just plug in for omega, we put 2 ej2t, and this is 1 plus j3, omega is 2. So this is the simplified relation. And now all you have to do is just manipulate a little bit. Pi gets cancelled. If we take 2 common from both, and this 2 pi or 2 also gets cancelled. So 10 left, and then here ej2t, and this will be j6. And similarly the second term. So we were here, and now from here we can actually convert this into a polar form. I hope you already know how to convert this into polar form. Use your calculator in complex mode, and then you can easily convert this into a polar form. So 6.082 angle 80.54. Now there's another formula that we have to use, because here is EJT. That formula is the different forms of impedance. So we know x plus jy is a rectangular form, r theta is the polar form, and then exponential form is r e raised to the power j theta. That means angle theta can be written as e raised to the power j theta. So here also we'll write that this angle will write e raised to the power j theta. So e raised to the power j is the angle here, and similarly here. Now if we take it up, it can be subtracted. So first of all, 10 divided by 6 point this will be 1.64 from both. Then e raised to the power j 2t minus this angle, so minus 80.54, j common taken. And then now we'll use another formula, and that is, I hope you know the Euler equation, e power ix or jx plus e minus jx over 2 is cosine x. So we'll just manipulate a little bit this, and that manipulation is that we divide this by 2 and multiply by 2. So now we can apply this formula. This multiplication is 3.288, and this will be cosine of x. Now this is x. So this is cosine of 2t minus 80.54. And so this is our answer. So this is the answer in time domain. Hope you have been able to follow this. Please let me know through your comments. Thank you.